Welcome to video 2 in lesson 8-4. Now that you guys are comfortable with making box and whisker plots, what we're going to do now is take a look at the ways that we can describe box and whisker plots based on their shape, as well as look at how we can determine what type of distribution our original data set may have. Now, like with our histograms, we are going to lose our individual values. We are not going to be able to see what each individual data set is. So any estimates that we have for the mean or the range or anything like that are all going to be estimates. But we can get a good idea of how the data is going to be spread out based on the shape. So just like we talked about with histograms, we can talk about skewness with our box and whisker plots. If we have a box and whisker plot that is skewed left, the left side of the box is going to be larger than the right side of the box, and the left whisker will be longer than the right one. Whichever side is going to be larger is the one that's going to be pulling the skew. If you think about it, as we talked about our histograms and dot plots, this is kind of the tail that's pulling things off to one side or the other. When we look at a symmetric box plot, it's going to have about equal length whiskers and boxes. It's not going to necessarily be perfectly equal, but they will be fairly close to the same size. And finally, in the box plot that is skewed right, the right side of the box is going to be larger than the right side. Sorry, that's definitely a typo that is going to need to be fixed. The right side of the box will be larger than the left side, and the right whisker will be longer than the left one. I think we got a little copy and paste happy there. Make sure that you have made those changes in your notes to make sure that you're not comparing the right side to the right side, but instead you're comparing the left side and the right side together. So again, just to summarize, since we had a little confusion there, if it is on the right side, where the right box and the right whisker are the longer ones, then it's going to be skewed right. Alright, now that we've talked about skewness and we fixed that little typo, we can also talk about where certain percentages of the data are going to fall. So, if we are looking at a box and whisker plot, each section of the box and whisker plot is going to hold 25% of the data. So in my lower whisker, that's going to be 25% of the data. In my first box, that's also 25% of the data. My third box is also 25%, and my fourth box is also 25%. So we would say that 25% of the data falls within each quartile. So 25% falls between the minimum and the first quartile. That's our first whisker right here. 25 is going to fall between Q1 and the median. 25% is going to fall between Q2 and Q3. And 25% of the data is going to fall between the third quarter and the maximum. No matter how long the sides are, you can see in this example, for example, that this whisker is a lot longer than this whisker, but it doesn't matter. We're still going to have 25% of our original data within each block. This 25% of the data would just be more spread out than this 25% of the data. This 25% of the data would be closer together and more compact. Now, based on the fact that we have 25% in each quartile, we can also draw a couple other conclusions. So, for example, if we're looking at the median, which is right in the middle, that's going to be containing two different sections. So if we add both of those sections together, and we add the 25% from each section, we're going to find that 50% of the data is going to fall below the median. So we can use the same logic to do it on the other side. We have the 25% from here, and the 25% from this whisker. When we add those together, that's going to also give us 50%. So 50% of the data is going to lie above the median. And then we can also look at, in between the boxes here, that's two sections of 25%. So if we add those together, it's going to give us another 50% that's between Q1 and Q3. So again, just each section that you're looking at is another section of 25%. So if you're looking at three sections, that would be 75% and so forth, and you can logic it out from there. Now for example 3, we were wanting to know what percent of data scored above a 7 on example 1. So I'm going to flip right back up to example 1 for a moment, and I'm going to go back to that box and whisker plot that we had made on here. So I'm looking at what scored at or above a 7. So that was right here. That was my Q3. So I have exactly one section of data that is above that. So remember, we said that each section was 25%. So I have 25% of my data that's going to be a 7 or above, and that's going to be my answer. All right, then example 2, we were asked, or sorry, part of example 3, we were also asked, would example 2 be best described as skewed or symmetric? If skewed, in which direction? So I'm going to look back at my example 2. Now this looks pretty evenly distributed. We do have the outlier that's affecting things a little bit. This is a little shorter because of that. But overall, our boxes are pretty much the same size, and the whisker's just a little bit longer on the left. You might be able to make an argument for skewed left, but I think our best answer on this is going to be symmetric, because for the most part, it all was pretty much the same. Now, we'll make sure to give you a clear example on a mastery check or a test where it's going to be obviously skewed one way or the other, but sometimes it's just a judgment call. And as long as you can kind of reason it out with us, we're usually going to be pretty understanding on what you decide. All right, so you have a couple you-try problems to attempt, and then some practice sections, and then you guys only have 2 more lessons left in Unit 8, and that will wrap up all of our video units. How exciting. All right, see you guys later.